It was economist Alan Greenspan who said, "Anything we can do to raise personal savings is very much in the interest of this country." In this lesson, we're going to define the basic vocabulary of savings accounts, and we are going to compute simple interest using the simple interest formula, all to be able to answer the question, what type of saving accounts do banks offer customers? To make sure we're ready for this lesson, let's go ahead and do warm-up number 2 and show that two equations are the same. Now, we already have an A equals equation in A, so how about for B, we solve that for A? Multiply both sides by D so that we get CD is equal to 3BD minus A. Move A to the other side, making it positive. We can also move CD to the other side, making that negative. So we have A equals 3BD minus CD. Now, these two don't look exactly the same, so we can distribute that D in the original equation, giving A is equal to 3BD minus CD, and now both equations look the same. Now, let's take a look at a problem that you will be able to do at the end of this lesson. Kerry invests $5,000 in a simple interest account for 5 years. What interest rate must the account pay so that there is $6,000 at the end of 5 years? We know that the interest that we want to earn is $1,000. That's the difference between the $5,000 in there and the $6,000 that they want to have. The principal amount is $5,000. Now, the rate is unknown to us. What we're actually going to do is use the I equals PRT, and we're solving for R. This means that I divided by P times T will equal R. The time frame is 5 years. So now R is equal to 1,000 divided by 5,000 times 5, meaning the rate we want to get is 0.04 or 4%. Most banks offer savings accounts, money market accounts, certificates of deposits or CDs, loans, life insurance policies, safe deposit boxes, and credit and debit cards, as well as checking accounts. Banks provide these services so that they can attract customers to make a profit. A savings account is an account in which the bank pays interest for the use of the money deposited into the account. The money on deposit with the bank is used by the bank to give loans. The people who borrow the money from the bank must pay it back with interest. The interest they pay is greater than the interest the bank pays for the use of customers' money. This way, the bank is able to pay depositors interest and still make a profit. Interest is based on the interest rate and principal or balance. The interest rate is a proportion of the balance that will be paid to the bank. The annual percentage rate, or APR, is a yearly interest rate that is paid by the bank, expressed as a percent, and there are two classifications of interest: simple interest and compound interest. Simple interest is explored in this lesson. It is interest that is based on only the original principal. Is there risk in putting money into savings accounts? The Federal Deposit Insurance Corporation, or FDIC, guarantees the safety of money in a bank by insuring the depositor for up to a specific amount. In 2019, the amount was $250,000 per depositor per bank, depending on the type of account. One depositor can be covered for more than $250,000 if they have different types of accounts in the same bank. It is important that all customers be aware that this amount is changed. If the bank fails, the money is replaced by the federal government. Banks offer forms of savings accounts. The most common savings account is a statement savings account, where you receive a monthly statement showing all activity, including deposits, withdrawals, interest earned, and fees. Some savings accounts require a minimum balance. With certain accounts, a fee is charged for each month the balance falls below a minimum amount. Some banks do not pay interest if a savings account falls below their minimum level. Another popular account is a money market account. It is a higher interest rate, but usually requires a greater initial deposit and a greater minimum balance. You may be limited to a certain number of transactions per month in a money market account. A certificate of deposit, or CD, is a certificate that states you have a specific sum on deposit and guarantees the payment of a fixed interest rate until maturity, which is a specific date in the future. Maturity dates can be from 7 days to 10 years. Usually, the longer the term is, the higher the interest rate. You cannot make deposits or withdrawals from a CD without penalty. All banks report rates as annual rates. When choosing a savings account in a bank or which bank to use, compare interest rates. Also consider penalties, fees, minimum balances, and other banking services. As you can see, there are many benefits to keeping your account in a bank rather than a piggy bank or at home. A piggy bank pays no interest and it is not insured. In reality, all people do need to have money on hand. It is not advisable to keep every cent you have in the bank. It is common practice for people to collect coins at the end of the day and put them into a jar. For example, if Joe buys a cup of coffee each morning for $1.50, he pays with two $1 bills, he gets 50 cents in coin in a jar at home at the end of the day. This problem can be modeled with an arithmetic sequence. In an arithmetic sequence, the difference between the two consecutive terms is a constant. The constant that represents the difference between consecutive terms in an arithmetic sequence is called a common difference. Subscripts are used to indicate where in the sequence a specific term is. The first term denoted by a sub 1 and the nth term denoted by a sub n. The common difference is denoted by d. An arithmetic sequence can be finite, which means it ends, or infinite, which means it never ends. The following are two examples in an arithmetic sequence. The one that ends with a period is finite, and the one that ends with the ellipsis ... is infinite. In arithmetic terms, we can see this here on the screen. Look carefully at the subscript of the terms you want to compute. Then look carefully at the coefficient of d and compare. The pattern shows that a sub n is equal to a sub 1 plus n minus 1 times d. This expression makes sense because to arrive at the nth term, the common difference has to be added to the first term, n minus 1 times. Lisa has a glass jar in her office that she's going to use to collect coins. She started by putting $11.25 in coins she already had. She pays for her commute to work each day and receives 70 cents in change and will add 70 cents into the jar each workday. After 100 days, she will take all the change and deposit it into her bank. How much will she have after 100 days? So we start with this idea of y is equal to mx plus d. Now remember, a sub n is equal to n minus 1 d plus a sub 1. This is similar to the y equals mx plus b formula we're so used to. A sub n is equal to n minus 1 times d plus a sub 1. So the 100th day, the 100 would go in for the n, 70 cents is how much she saves every day, and the starting point of 11.25 is our b term. So after 100 days, she will have $80.55. Now let's check our understanding and find the common difference for this infinite arithmetic sequence. What we can simply do is subtract the previous term. So 223 minus 11 is going to give us that it went up 12. And 235 minus 223 will also give us 12. So if I just say 235 and add 12, do I get 247? I do. So the common difference is 12. Grace wants to deposit $5,000 into a CD for a period of 2 years. She's comparing interest rates quoted by 3 local banks and 1 online bank. Write an interest rate in ascending order and which bank pays the highest interest for the 2 years. So the decimal can be easy to keep a hold of and looks rather uniform. This lets us leave both of those in place. 1 1/4 is the same as 1.25%. 1 3/8 is 1.375%. From lowest to highest, we're going to get a 1.22%, a 1.25%, a 1.3%, and then a 1.375%. So the highest interest rate is paid at 1.375, which means the e-savings bank. Raoul's savings account must have at least $500 in it, or he's charged a monthly $4 fee. His balance was $716.23. When he withdrew $225, what was his balance after the withdrawal? Well, he had the $716.23, withdrew $225, leaving him at $491.23, which is unfortunately less than $500, so he has a $4 fee, which now leaves him with $487.23. Let's check our understanding, and May has $891 in her account. A $7 fee is charged each month to balances below $750. She withdrew $315. If she makes no deposits or withdrawal for the next X month, express her balance algebraically. So we know she has $891 and she withdrew $315, leaving her at $576, which is less than the $750 that needs to be there. If we lose $7 for every single month, X in this case, because they told us, then we get the expression 576 minus 7x. Michelle deposits $1,200 into an account that pays 1.5% simple interest. He keeps the money in account for 3 years without any deposits or withdrawals. How much is in the account after 3 years? So our formula is I is equal to P times R times T, where P is the principal, R is the rate, and T is the time. It's important to remember that rate is as a decimal and time is measured in years. So we wind up doing 1,200 times 0.015 times 3. Gives us an interest earned of $54. But let's remember that there was the principal in the account of $1,200 to begin with, so we can add that to get $1,254. Let's check our understanding of this and see how much simple interest would be earned on $4,000 in 3.5 years at an interest rate of 1.2%. Now we know the simple interest formula is I is equal to PRT, and in this case the principal amount is $4,000. The interest rate is 1.2%, so 0.012, and 3.5 years would be 3.5. This means that I is equal to 4,000 times 0.012 times 3.5. The simple interest earned would be $168. Now pay attention because it asked only about how much simple interest is earned. It didn't ask about the entire balance of the account. So how much simple interest does $2,000 earn in 7 months at an interest rate of 2%? And round this to the nearest cents. The trick they try to give us here is 7 months. Remember, 7 months out of 12 for the year, so our time frame is going to be 7 over 12. Knowing that I is equal to PRT, the principal amount of money is $2,000, the rate being 2% is 0.02, and our time is 7 over 12. So, by simply putting all those numbers into the formula to find that simple interest, then the interest would be $23.33. Let's check our understanding of that and see how much simple interest would $800 earn in 300 days in a non-leap year at an interest rate of 1.71%. So we know that the interest rate is the principal times the rate times the time. Principal is 800, the rate is 0.0171, and 300, and they're very specific about that being out of a normal year, 365. This means that I is equal to 300 times 0.0171 times 300 over 365. Using that calculator, you get $11.24. How much principal would be deposited to earn $1,000 simple interest in 2 years at a rate of 1.3%, and round this to the nearest cent? Now we're asking a question in reverse, where we know all the information except how much we have to deposit. So the interest rate divided by the rate times time will give me the principal amount that has to be invested. We're trying to earn $1,000 interest at 1.3% interest over 2 years. This means P is 1,000 divided by 0.013 times 2, or the principal, the amount of money you would have to deposit, is $38,461.54. Let's check our understanding of this and see how much principal must be deposited in a 2-year simple interest account that pays 1.75% with an interest earned of $300. Now, we already know that the principal is equal to the interest divided by the rate times time. So P would be equal to 300 divided by 0.0175 times 2. This is going to give us $8,571.43. Derek has a bank account that pays 2.1% simple interest. The balance is $910. When will the account grow to $1,000 and round to the nearest month? Now, we already know the simple interest formula, that interest is equal to PRT, but we want to solve for T. So we can divide both sides by PR to get T. This means that T will be equal to 90 divided by 910 times 0.021. Why 90, you say? Well, he wants $1,000 in the account, and he currently has $910. By subtracting that, we can find the interest number that we were actually after. Doing the calculations to find T, doing this, we get 4.71. Now, this is 4.71 years, remember. So we need to multiply this by 12, which is going to give me 56.5 months. Being 0.5, we can call this 57 months. Now, let's check our understanding and say, how long will it take $10,000 to double at 11% simple interest? The thing about saying that it doubles is I know the interest earned is $10,000. I also know the principal amount is $10,000. The interest rate given is 11% or 0.11. That means that the time will be equal to 10,000 divided by 10,000 times 0.11, which is 9.09 years, or 9 years. Kerry invests $5,000 in a simple interest account for 5 years. What interest rate must the account pay so that there is $6,000 at the end of 5 years? We know that the interest that we want to earn is $1,000. That's the difference between the $5,000 in there and the $6,000 that they want to have. The principal amount is $5,000. Now, the rate is unknown to us. What we're actually going to do is use the I equals PRT, and we're solving for R. This means that I divided by P times T will equal R. The time frame is 5 years. So now R is equal to 1,000 divided by 5,000 times 5, meaning the rate we want to get is 0.04, or 4%. Let's check your understanding. And Marco deposited $500 in a 2.5-year simple interest account. He wants to earn $50 interest. What interest rate must that account pay? We can always remember that R is going to be equal to I divided by PT. We figured this out already. Now, the interest rate that we want to earn is $50. We already know that the principal amount is $500 and that the time frame is 2.5 years, which means we can use our calculator and get 0.04, or 4%.